Current transformers are used to transform standardized primary currents into standardized secondary currents. The AC currents converted in this way are much smaller than the primary flowing currents and can be directly processed by the connected protection control and measuring systems. In this video, we look at the basic operating principle of an inductive current transformer. The basic principle of the transmission of current transformers is simple: electromagnetic induction. Electromagnetic induction is part of Maxwell's equations and classical electrodynamics and reflects the state of knowledge at the end of the 19th century. According to its principle, an alternating magnetic field induces an electromotive force E within a conductor loop. Such a constantly changing alternating field can be easily generated using a coil by applying an AC voltage to the coil. The alternating current flowing through the connector now generates a radial magnetic field along the conductor. The resulting magnetic field of a coil then looks like this. Due to the steady changing direction of the current, the magnetic field of the coil also changes its direction. As a further elementary component of the current transformer, we now carry a ferromagnetic material, for instance an iron core, through the coil. The magnetic field of the coil is bundled in the iron circle and the magnetic flux phi is created as the sum of all magnetic lines. This periodically changing magnetic flux now induces a voltage in a secondary winding, which in turn drives a secondary alternating current. By the rule of Lenz, it follows that the secondary current and the resulting magnetic field counteract the magnetic flux of the iron core. Since the magnetic flux of the iron core is the same in both windings and the primary and the secondary coil have the same number of turns, we will get the same currents on both sides. In this case, the primary current equals the secondary current. If we now increase the number of turns of the primary winding, the secondary side current also increases. The ratio between primary and secondary side is: the number of primary turns Np are related to the number of secondary turns Ns, as is the secondary current Is to the primary current Ip. If we reduce the number of turns on the primary side, the resulting current on the secondary side also decreases and we get the typical transmission characteristic for current transformers. Thus, small standardized secondary currents are obtained from large standardized primary currents in order to be processed. In the power supply, one current transformer per phase is used to measure the usually three-phase current systems.